Hello, I think this is the last video in this chapter, so we have a few more topics to cover, which will be very brief. So the first topic we discuss in this video is about the model specification. The model specification is what combinations of variables you are going to use in a regression. So which variable to choose, which variable to include, and which variable not. So in many textbooks, there are some mechanical ways, but I don't like those mechanical procedures. And I agree with these authors, the textbook, that you have to think using your economic intuition. So let's think about this. First, you have to identify the variable of interest, which is obvious. So you have to start with your own research question. What you want to study. So then you have to fix at least one or two variables, important variables, you have to include no matter what. And then second, think about the potential problem like omitted variable bias. You would like to estimate the effect of student-to-teacher ratio on the test score, but by just considering these two variables, your estimator will be biased, because you don't observe a lot of factors that also affect the test scores, but at the same time correlated with the student-to-teacher ratio. For example, so think about the potential determinants, and then think about if they are available. If they are available, then you have to include those variables. If not, then think harder, and if there is any available data related to those unobserved factors. If possible, try to include as many controls to approximate the unobserved factors. So there may be multiple variables that can be used for the same role. So then, and just depending on your judgment, your intuition, and your belief, make a benchmark model, say the base model. So this base model includes, of course, the important variables and some key control variables. Well, some of them may not be important, but still you have to have you should have a model that you believe the best. And then, however, so many students try to use only one model because they think there is only one true correct model. But I don't think so. There is no one correct model. You have to try many different models, and you have to see how they change. There must be some systematic patterns from different models. When you include a variable, you need to see how other estimates change. And when you drop another variable, then what's the difference? So your conclusion must be coming from comparing different models, and if they are consistent with each other, that's the best. So if you try different variables, but all of them indicate the same conclusion, that's the strongest conclusion. So that's the best desirable situation. Still, even if that is not possible, you have to think about the changes, how the patterns of the results when you change the model. So it is called sensitivity check. So whether you include more variables, the coefficient may decrease, which implies the original coefficient was overestimated, something like that. But as I said before, so statistical procedure is just a secondary way, cannot be the main decision rule. The main decision rule must be your judgment, your research motivation, and your view of the world, what you think about the problem. So do not rely on a simple rule such as higher R squared is the best, something like that. So this is a typical mistake about the R squared. I think I said it earlier. Higher R squared is good. Surely it is good. It means that the regressors explain more about the outcome. However, it cannot be an objective. It is not your purpose. Your purpose is not to maximize the R squares, but to include correct variables, reasonable variables. So you have to understand that high R square does not imply that you have eliminated the omitted variable bias. So it has nothing to do with omitted variable bias. And higher R squared does not mean you have an unbiased estimator. So same thing, or still, even if R squared is higher, still there may be omitted variable bias. And higher R squared does not mean that the included variables are significant. So there may be. So as I said earlier, higher R squared can be obtained by including any variable. If you add any variable to the regression, R squared is only increasing. So it is not an ideal way of doing estimating the regression model. So the significance must be considered separately for each coefficient or a pair of coefficients. R squared does not say anything about statistical significance. So be careful. Many students rely too much on one or two measures, but that can be very dangerous. And let's think about an application of that principles to the test score data. So first, it is clear that our interest is on the student to teacher ratio. And then think about the omitted variables. So like for example, whether the students know English, outside their students outside learning opportunities, parental involvement, teacher quality, and there are more like district wealth and teacher salary, and a lot of things. So if you can observe them, that's great. Like for example, whether the students know English or not was nicely captured by the percentage of English learners. I think that's a good variable. And but outside learning opportunities, this is not easy to measure. Maybe there is no data like this. Maybe this is related to the family income. Maybe family income could be a possible measure. And or if there is any survey about children's activity allocations, what they do usually, that could be another possibility. And parental involvement, also it's not easy to measure. Maybe it must be correlated with family income, parents' education, or any surveys, how much they participate in school activities, something like that. So you can think about some variables, observed available variables that are related to these hidden factors. And teacher quality, of course, it is not easy. Teacher salary could be one a possible variable, or say the degrees, like how many teachers have master degree, or the experience of the teachers, or turnover rate, how often teachers like resign and hired. So like this, you have to think about what variables you can utilize and what's important and relevant. And then from there, you have to try a lot of things. You have to include and drop the variables and try different combinations of variables. So it takes usually when you do a research, this takes the most time. You have to see what is working, what is not working. It is not easy to guess what is the best model. So just try many different models, and still you hope to have a benchmark model. So basically some key variables must be equipped and then change from there. And also alternatively also the next step is for the same factors there may be different variables may be capturing the same thing. It's related to the multicollinearity. So for example, parents income or a parent's income must be closely related to parents' education level. So then if you use both variables at the same time, then the results may suffer from a multicollinearity problem. Then you have to drop one of them, but which one to drop? You have to try both. So you have to try both cases and see which is better. And then after estimating different models, you have to read how the results change. If there is any pattern you can find when you change the models. So it is the sensitivity checks. Right. So, and also it is helpful to make a scatter plot. So like percentage of English learners has a very strong relationship with test scores. Also, this is even more stronger relationship. Percentage of eligible for subsidized lunch. So the percentage of free lunch has even stronger relationship with test score. And this is percentage of qualifying for income assistance. So maybe these two are correlated, but when you look at the scatter plots, this free lunch variable looks better than this variable. Just thinking about from the graph, from the scatter plots. But you need to try both and see how they change, how the results change. And finally, this is about presentational regression results. I have explained how to report the results in a table in a previous homework guideline. So you need to include a table of regression results should include estimated coefficients, standard errors, measures of fit like R-squared or SER, standard errors of the regression, number of observations. So these are like these four are pretty much the requirement. So these must be included in every regression result. And if needed, you may include additional F statistics if you have a specific hypothesis to test. And also, if you are interested, you may include confidence intervals for some important variables. And then this is the result. So it looks more fancy, but basically this is the same structure as what you have done in homework 3. Maybe the only difference is that below each estimate, you see a parenthesis, and inside the parenthesis is the standard error. So this is 0.031 is the standard error for this estimate. And the first variable has confidence interval. But I don't think it's good, like it doesn't look clean. So I don't think it's helpful. Because if you know the estimate and the standard error, it is very easy to calculate the confidence interval by yourself. So I don't think confidence intervals are helpful in the presentation, but still the standard errors are important. So as I said, like this in this picture, in this table, you see that the X3 and X4 have been tried different ways. So the like model 3 includes only the percentage of subsidized income, and model 4 includes a percentage of free income. Model 3 is about free lunch, model 4 is about income assistance, and model 5 includes both. So, and it looks like when both are included, this loses significance, right? So it has to be negative, but suddenly it becomes positive, and it is even smaller than the standard error. So that means it is nearly zero. So that means maybe I would choose this model. Number 3 is my model. based on this analysis, because the choice is basically one of the three, because these variables are so important. Then you have to choose which is better. I would choose this one. Summary, you may read it when you have time. So this is the end of the chapter, and I may be uploading more videos to review for the exam and or review the homework. So good luck with the exam. Bye.